Okay, everyone, welcome back to another fun and excitement-filled week in online calculus. The purpose of this first video is to just introduce you guys to what section 4.1 is, kind of what basically chapter 4 is all about. Just get you guys introduced to that. Talk a little bit about some basic rules that we're going to use this week. And then on my next video, I'll do a couple of example problems for you guys so that'll help you on the assignment today, okay? So just a couple things to point out. We're starting with something called antiderivatives and indefinite integration. So this is 4.1 in your book. This Friday will be a quick knowledge check / mini quiz on the stuff that we do this week, so just keep that on your radar. Essential question is, how can we use basic integration rules to find antiderivatives? And then what you're going to turn in today is page 251, numbers 11 through 20. Okay? So when you look at the word antiderivative, okay, that's really what this whole chapter is going to be about. And it is exactly what it sounds like. It's the opposite of a derivative, okay? So in your notes, the definition, I know this might be a little tough to read, but the definition of an antiderivative is a function f, so capital F, is an antiderivative of f, lowercase f, on an interval I, when f prime of x equals f of x for all x in I. All right, wow, that was pretty crazy. I don't expect you to understand that technical definition right there. What I would hope that you would understand is just kind of the more down-to-earth version of the definition, which is you're working backwards from the derivative to find the original function, okay? So let's say you have, I'm just going to throw out, let me just use a different color here. I'll just throw out an example. Let's say we have f of x is equal to 3x to the second, right? And if we want to find the derivative of this function, as we've been doing for months and months now, we use the power rule, and this would just be 6x, right? We all know that. So what we're going to be doing in this unit is, if I were to cover up this original function and say, okay, we're going to start with this, and we want to work backwards to get to our original function. We did this a little bit in first try when we looked at graphs, right? We looked at the graph of a derivative and we tried to graph the original function. We're not going to be looking at graphs, it's just more of equations, okay? One of the things that we run into is, so if you start with 6x, and let's say this is a derivative, okay, so if we work back to our original function, okay, we could end up with 3x squared, okay? But how do we know that our original function wasn't this, okay? Because this would be the same thing, right? Because if I took the derivative of 1, it would just be 0, which would be nothing here. So there's actually there's a whole range of things that this could end up as. So what we do, going to my next page, when we're talking about notation for antiderivatives, whenever we write our answer for an antiderivative, we put a constant at the end of it, okay? So let me just explain to you what this all means. It says, this is read as the antiderivative of f with respect to x. Another word for antiderivative that we're going to use a lot is called integral, okay? Antiderivative and integral they mean the same thing, okay? So what this means is this little skinny s right here kind of looks like a, I don't know, music symbol or something that you'd use, I don't know where else, but so this means integral. This also means antiderivative, okay? So I'm going to write right here integral or antiderivative, okay? This is your function that you're taking the integral of. This tells you what you're integrating with respect to, okay? So if this was f of y, this would be dy. If this was f of h, this would be dh, okay? Okay, this denotes your original function that you got back to. Original function, okay? But like we said on the last page, you can get back to the original function, but how do you know that there wasn't a constant at the end of that just dropped, like a +1 or a +2 or a +100, okay? So we always add a plus c, or a plus constant, at the end of all of our answers, okay? So what, again, just going back, this means the antiderivative of f of x with respect to x is equal to the original function plus a constant, okay? So last page here, I'm going to give you a couple steps to write down. That'll be the end of this video. And then I'll go through a couple examples with you guys that, again, should really help you on your lesson today, okay? So the only thing that we're going to talk about this whole week is something called the basic power rule of integration, okay? So just like derivatives, integrals or antiderivatives have rules, okay? And the rule we're going to talk about this week is basic power rule, okay? So this tells you that if you're taking the integral or the antiderivative of x to the n, okay, your answer, or the way to get to your answer, is going to be in this form, using this formula, okay? And we're going to use that on our next few examples. When you guys are ready, once you've written these kind of bullet points down at the end and got your notes ready to go, you can click on the next video and I'll do some examples with you.